Hey there, folks. Mr. Dickin here, and in this next video and the few that follow, we are going to be kind of doing some e-learning stuff going on with probabilities. So we're all kind of uncharted territory here with regard to the e-learning days. As you guys know, the whole COVID-19 outbreak is being contained, which is why we are not seeing each other face to face. So I'm going to make these in the best effort to make sure you guys kind of understand the material. If at any point stuff does not make sense, please send me an email. I'll be checking my email several times a day throughout the next 2 weeks when we're not seeing each other. And my goal is by the time we do see each other again, we can kind of carry on where we left off. So, without further ado, today we're going to be talking about conditional probability. Conditional probability is basically calculating a probability of a certain event given that or assuming or operating under the condition that something else is already happened or something else is already guaranteed. So the symbol for this is a little vertical line. You know, it's the line that's directly above the enter key, right next to the shift or right next to the slash button. And this would be read as probability of event B happening given that or assuming event A has already happened or event A is guaranteed. Today, when we discuss these, we're going to be using what's called the contingency table or a two-way frequency table. And this is just a way to organize our data so that we can quickly gather some information. So without further ado, let's see some examples. All right, first and foremost, just to get in the swing of calculating these. We're wanting to know what is the probability of drawing a card based on the following criteria, given that the card drawn is black. So that's really the phrase I want to draw your attention to. So given that the card drawn is black. Normally, we would deal with cards out of 52, right? There's 52 cards in the deck. However, this is asking us to narrow our focus only on the black cards in a deck. So only on the clubs, only on the spades, of which there are 26 total. So first one is saying, what is the probability of selecting a club given that, or probability of selecting a club assuming that you're only looking at the black cards? Well, there are 13 clubs out of 26 total black cards. So it'd be 13 out of 6, or sorry, 13 out of 26, which of course reduces. Next, I have the probability of selecting a 4, given that I'm only looking at the 26 black cards. Well, out of those 26 black cards, I've got the 4 of clubs, the 4 of spades. So I have two options out of 26 total, so that'd be 1 out of 13 reduced. Lastly, I have what is the probability of selecting a diamond, given that I'm only looking at the black cards. So out of all 26 black cards, how many of them have a diamond? Well, none of them, because diamonds are red. All right, next up. Here we have a two-way contingency table. This table is comparing gender, male versus female, versus the type of schooling that someone has had, whether it's a 2-year, 4-year, or grad school. Now, it's not always going to be given to you, but I would strongly advise at the end of every row or at the bottom of every column, tack on a total where you can go through and quickly add up all the columns straight down, add up all the rows straight across, because these totals will be coming into play later on. And it serves as a nice little way to kind of double check these three values here should add up to the same number as these two totals down this way. All right, so let's see some examples here. First one says, what is the probability that we get a female? So there's no conditional aspect at all. It's just the overall probability that we randomly select female. So there are, let's see, 9,933 females out of a total of 17,472, which gives us a roughly 57% chance. Now, number two is saying, what's the probability you select female given that you are only looking at the graduate school students? So whatever comes after that little given that notation, that conditional bar, That's where I narrow my focus. So I'm only looking at the graduate school students. That's where I'm going to narrow my focus in. So the probability of selecting a female out of this group was 1,954 out of a total of 3,303. Well, that sounds like calculator work to me. That'd be 59%. So again, I'm taking the female students who are also in graduate school, dividing it only by the graduate school numbers. Lastly, what is the probability of selecting a four-year student given that that student is a male? Well, for this, I only care about the male students, right? Because this is saying we're operating under the condition that the student is a male. So I don't need to look at the total student body, just the males. So out of the 7,539, how many are attending a four-year school? That would be 4,324. So we go straight to our calculator. We get a percentage. We round. Shaboom. All right, next. Very, very similar type. Here we have another two-way table where it's asking us to figure out some contingencies, right? So we have conditional probabilities that will end up showing up, like problems 3 and 4 down here. I'm seeing that little vertical line, which means given that. You'll also notice one thing that was not given to us in this table was the totals. So in blue ink, we have the total for high school diplomas, yes or no. And over here, we have the totals for having experience, yes or no. Both totals, regardless how we add, should equate to the total of 90. All right, so problem number one. What is the probability that a student has a diploma? Well, 81 out of the 90 people have a diploma, so the probability would be whatever 81 divided by 90 is, which is 90%. Number two is saying, what is the probability that they have a diploma and experience? So here they're meeting two criteria. So they have a diploma and they have experience. That refers to this 54 people, or these 54. Wow, I cannot speak. Those 54 folks right there, out of the overall total, wait for it, of 90. Now, 3 and 4, this is where we get into the conditionals. Number 3 is saying, what is the probability they have experience given that they have a diploma? So now I'm going to narrow my focus. I only care about the folks who have a diploma. So I'm only looking at these specific 81 people, not the total 90, just these 81. Out of those 81 folks, how many of them have a diploma? Well, that would be 54 out of 81. We go to our calculators and we're going to find that it's about 2/3. Problem 4, what is the probability they have no diploma given that they do have experience? So again, right here, the fact that they have experience, and that comes after my given that statement, that's where I'm going to narrow my focus. So I only care about the folks who have experience. So I only care about these 59 total people. Now, of those 59, how many of them do not have a diploma? Well, that would be 5. So 5 out of the 59 do not have a diploma, which equates to 8%. All right, this next one. I'm going to ask that you guys go ahead and pause the video right here, so that way you can read through this and get the answer yourselves. And in about 10 seconds, I'm going to unveil the answer, and I want you to kind of use this as a self-assessment opportunity to see how well you're gathering the information. So I want you to say, what is the probability that someone applies shampoo directly to their head, given that they are female? So again, pause the video and see what you get. All right, if you got 6 out of 30, so these 6 people out of the 30 females, you did it correctly. And yes, I know you may be wondering what kind of psychopath throws shampoo directly onto their head instead of into their hands first. I don't know. Seems awfully wasteful to me too, but it is what it is. All right, onward we go. Sometimes we won't always have information represented with a data table. So it's not really going to be conducive for us to make a table, so we have to rely on just basic formulas. So here's a formula for conditional probability. And this is what it says. It says the probability of event B given event A has already happened. To calculate that, you would take the probability that both things happen, and you're dividing it only by the probability of the first event. And we've kind of already been doing this. I'm going to skip way, way back to this first one, right? Like if I look at number 2, the probability that I selected a 4, given that it was a black, well, there were only 2 black 4s out of the 26 black cards. So that is, again, the probability of both over the probability of just the second event. So whatever came after that conditional piece. So let's see an example, shall we? If you need to pause this to jot things down, please feel free. So here we have survey results about folks who either currently have pets or maybe they've had a pet in the past or they've never had a pet. You can read up here. Problem 1 is saying, what is the probability that a respondent has had a pet given that they have had a pet? So here it might be easiest if we write it first in our conditional probability notation. So what is the probability they have a pet given that they have had a pet in the past? So the second statement here is going to be, what is my new denominator? What is my narrowed focus? So it looks like 86% have had a pet. And then the numerator is going to be, well, what is the probability of both? So folks who have a pet and have had a pet. So I'm seeing that that seems to be the 39%. Let's see. Sure enough, 39%, which satisfies both of these, so that's these folks right here, over the have had a pet population, so the 86 down below. Number 2, find the probability that a respondent has never had a pet, given that they do not have a pet now. So again, this might be in your best interest to write in probability notation. So my denominator is going to be only the do not have a pet folks, and my numerator is going to be the number of people who satisfy both of these requirements. So the bottom number is does not have a pet now, so 61%. And the numerator is going to be never had a pet and they don't have a pet now. And that looks to be 14. Let's see if we did it correctly, shall we? Oh, 14 out of 68. 68, whoa, what am I saying? 61, my bad. All right, so that is it for conditional probability. You guys will see problems written in 2 separate ways. One, you might see a contingency table or a two-way table, and you'll just have to pay attention to what are we narrowing our focus down to. Or they might give you a problem like this where they just give you raw data, not in a tabular or table form, in which case you will have to rely on this formula here. So this should be enough information to get you guys going through the assignment online. If something is not making sense, please, 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 please let me know. If you need extra homework attempts on the problems, it defaults you to 3. If you need 30, let me know, and I'll give you guys more attempts. All right, good luck, have fun, be safe, roll tide.